Right, and the last one of these applications for just now is talking about a plane. So we've got a plane passing through a point, so let's just have any point, we'll call it A, so this is point A, and has the unit vector n as a normal. So somewhere, the things don't have to be particularly close together, so we'll have a normal vector. Okay, so what that means is that we've got a plane, so I'll just draw myself a plane, I'm not staggering good at drawing these sort of things, but we've got a plane, and point A is on that plane, and n is at right angles to the plane. And the origin could be anywhere, it doesn't have to be particularly close to A or anything to do with normal, so we'll just chuck the origin down here. And the question is to find the perpendicular distance of the plane to the origin. So there must be some point on the plane which is the closest point to the origin. So that there, where this angle in here, in fact the angle to any point on the plane will be a right angle, because the shortest distance will meet the plane at right angles. And then we're going to have an angle down the bottom here. And what we're trying to do is we're trying to work out this length here, P, the distance from the origin to the plane. So we'll call that P. And, excuse me, by a simple trigonometry again, we have that the length of P is equal to the modulus of A times the cosine of theta. Okay, where A is going to be the position vector from the origin to the point A, and just using SOHCAHTOA, tells us that P is the modulus of A times the cosine of theta, which is equal to, subtle trick again, oops, put a line in there, the modulus of A times the modulus of N times the cosine of theta, because N is the unit again. Okay, so N is a unit vector, so we're multiplying that by 1. It doesn't change it at all. And then that, by definition, is just equal to A dot N. Okay, it is important that N is a normal to the plane, because the angle between P and A is equal to theta, and because N and P are in the same direction, then the angle between N and A is also equal to theta. So you couldn't just slip a vector in here that was at a different angle, because it would change the theta. So the fact that P and N are in the same direction is really important to keep that theta the same. But once we've got that sorted out, then it's not too bad to work out the distance that we're trying to find, because all we need to do is do A dot N. So A dot N is equal to 1 times 2/3, negative 3 times 1/3, so we'll do it all in thirds again, minus 3/3, and minus 2 times minus 2 is plus 4/3, which gives us 6 minus 3 is 3/3, I think, which is just going to be equal to 1. So the distance is 1, which is coincidental. It's not going to be 1 every time. It's just this case it happened to come out to be 1.